Hello, everyone. It's me, Carolyn, and in this video, we are going to be talking about how to find percentiles using the standard normal, and then we will eventually transfer that to just any situation, being able to find the percentile of a certain value or to find a value that represents a certain percentile, like what is the 30 scored represents the 38th percentile. Or if a person scores this, what percentile are they in? So again, we have to first of all remember what the word percentile means. So a percentile is the percentage of, or the proportion, if you're talking about a decimal, of observations that fall at that value and down. So thinking in terms of the standard normal, it would be standard normal is at 0. So finding the probability of this piece at that value or smaller. So let's look at a few examples. Again, we will be using SALT to help us get those actual numbers. SALT, again, is a Cengage product that is linked to a lot of their textbooks. And the first ones we're going to look at are going to be just looking at the standard normal. So again, we're going to be looking at a Z value. So anytime we talk about a Z, we are referring to that standard normal with a mean of 0 and a standard deviation of 1. So kind of keeping that in mind. So here we're looking for what percentile corresponds to a Z score of 1.25. I will draw a picture for all three of these. Well, we'll kind of go back and forth, I think. So is normal curve. So that's why I'm going to draw my bell. I am going to make it's somewhat symmetric. It should be symmetric, but mine tend to not be. Since it is the standard normal, it is centered around the mean, which is 0. We have a Z score. So that's going to tell me the value along that axis down here. And it's a 1.25. So that's going to be up on this side of the 0. If it was negative, we would have been on the other side. And we are looking for the percentile. So we are looking for the percentage or proportion from that value or smaller. So we're going to be looking at that left tail. So again, we're going to go to SALT. So please bear with me while I shift back and forth. But in SALT, if we were bringing ourselves right into SALT, we want to make sure we're in the distribution calculator area. I am using the normal distribution. We're doing the Z, so it is a mean of 0, standard deviation of 1. We will be doing a left tail because we're at that point or smaller, and we want a 1.25. 1.25. So getting this decimal, that's 0.89435. Notice also when we are using the standard normal and we look at that Z-score, the Z-score does match the value that we put in. So that's another way to kind of double check that we are using a Z. Yeah, I always use my pictures to help make sure I'm doing it the right thing. I look at what they give me. So all of that piece. Okay, so it's going to update here a little bit. And so my percentile in decimal form as a proportion is 0.89435, or a score of 1.25 is in the, and I'm just going to round to the nearest whole, the 89th percentile. Okay, we're going to do another one. Here we're looking for what percentile corresponds to a Z-score of a negative 1.4. Or this could have been written in a different format. So kind of watch the reading because they could have said 1.4 standard deviations below the mean. So this automatically tells you that it is a Z-score because it's telling you how many standard deviations you are. So that is a Z-score. And since it was below, that means we're looking at a negative. So kind of watch for those values. Okay, so here's my 0. We are looking for a negative 1.4, so that's down on this side. And we are looking for percentile, so percentile is always that value or smaller, so going off to the left. So again, we'll go to SALT to get that value. You can use tables if you like to use the tables. Whatever is more comfortable with you. My students here have access to SALT, hence the reason I'm making these videos using SALT. So I'm going to steal this number here, 0.08076. And we will go back to my camera. And we'll let this update. So we get that 0.08 or a score that is 1.4 standard deviations. I'm going to abbreviate here, deviations below the mean. Oops, below the mean is in the 8th percentile. Okay, here's a different type of question. This is asking for what is the z-score that represents the 50th percentile. So in other words, they're asking for the score. So we're looking for the number down on this line. So we get 50% that is going to be at or less than it. So 50%, that's half. So that would be smack dab in the middle. So we're looking for the value that's smack dab in the middle. And that would be our mean, which is 0. So the mean, if you're talking about a normal curve, does not happen for all curves, but it does happen for the normal curve, is the 50th percentile will be your mean. All right. Sometimes we do this a little for other pieces that we're given the percentile and we're looking for the score. And then we have to be a little bit different when we go to our technology. So what this means, the 50% is we look for here. Sometimes we're going to be representing those with a Z star. So if you're looking for a Z star that represents the 38th percentile, so you may see that star notation. I haven't seen it used a whole lot with percentiles. I've seen the Z star used for other pieces. All right. So let's find the z-score that represents the 38th percentile. Okay, and I always try to make sure that I draw a picture that's pretty close. Okay, we are still talking about a z-score. So we are still talking about our standard normal. So that means the 0 is in the middle. Now 38, trying to figure out if I'm going to be on this side or this side of 0. And the way I remember is with this piece that I just talked about up here. 50 percentile is the middle. So we're looking for smaller than 50. So that means I'm going to be on this side here. So I'm going to be looking for my 38th percentile. So this area that's in here is where that 38% is, or that 0.38 is there. And I'm looking for this value here. So it should turn out to be a negative value because we are below the 0. So let's see what SALT does for us on how to find these types of questions and how we work with those. So it's going to be a little bit different. Okay, still going to do a left tail. We are still using our Z, so mean of 0, standard deviation of 1. I don't know this piece that's in here. This is the part that I know. Luckily, I can enter things into here as well. So I can put my 0.38 in this area here. And notice that I do get it on the left side of 0. I do get a negative value. So the z-score that I needed was a negative 0.3055. Okay. So that is my z-score. Notice it's also down here as well, the z-score. Those two things do agree because we are working in that standard normal. Okay, going back to my screen, my other screen. Okay, so we get that z-score here. I'll put it in my box. A negative 0.3055 to kind of finish my story. Okay, we can also see it represented different ways. And after I go through these couple examples, we'll do one that is not your standard normal. So we're going to find the z-score that represents the middle 50%. Okay, so if I'm looking at my picture, this is what this means. So we're looking for the z-scores that represent the middle 50%. So when we talk about 50%, we're going to go middle, we're going to go even direction both ways. And what we want to have happen is we want this middle to be the 50%. And we're going to be looking for these two values here. Now, since we're talking a normal curve, it is beautifully symmetric, even though my picture is terribly not symmetric. This should be beautifully symmetric. These two values will be equally spaced from 0, because that's the way we want to find the middle 50%. We don't want it being skewed one way or another. So these numbers will be the same. One's going to be positive and one's going to be negative. So we want that middle to be 50%. So we're going to go to salt, and I'll show you how we're going to do that. So going to salt. Okay, now we want to find the middle. So we're going to be looking for two values. So we want to do a between, because we want that 50% to be between two numbers. So I'm going to put that 50% as my answer. So 0.5 as my answer. And you'll notice I did get two values, one being positive, one being negative, and 50% is in that, in between those two. I'm going to write those numbers down. So 0.6745. So we used the between because we wanted to sandwich the 50% between two values. The 50% was our answer, the area in the curve, the probability answer. And we're looking for the two scores on the line to give me that piece. Okay. So I'm going to have that 0.6745 down here. And on this side would be the negative 0.6745. All right, last one with just the standard normal. And we're looking for one that represents the upper 5%. So the key to these problems, first of all, is to make sure you read them carefully. We are talking z-score, so normal, standard, normal, centered at 0, standard deviation of 1. We are looking for the upper 5%. Now that's a small value. So I'm going to draw kind of a small piece. Upper would be kind of this direction. And we want this to be 5%. Now remembering 5% as a decimal is 0.05. And we're looking for this number right there. So here we go to solve one last time in our standard normal. And I want to do an upper curve, upper tail. So that's going to be a right tail. Notice it switches to the right. And I don't want my answer to be 0.5. I want it to be 0.05. And you'll see the tail get really a little bit smaller. And we see that 1.6449. So I'm going to put that on my sheet, 1.6449. And I'm going to go back to my screen one last time. I'll be jumping back to salt again for these other examples, but okay, so I got 1.6449 for that area. Now, if we were doing this using tables, this becomes a lot more difficult because these percentages we would have to look for inside of our table and then find the z-score that mapped to it. It does take a little bit more work with the tables. Technology makes this system so much faster, than the tables. So hopefully those of you that are watching this video have access to some sort of technology that can take away all of that searching for you. Okay, we're going to look at some just random questions, random problems, and see how it will change. And I do have a couple of examples here. And I don't know if I'll go through all of them, but I probably will. So here we have a test of some sort. I don't know if it's a math test, stats test, reading test, who knows? But it has a mean of 65 and a standard deviation of 7. So we do have a normally distributed, so I'm going to draw my normal curve. So my little bell curve kind of went off the page, sorry. It has a mean of 65, so that tells me 65 is in the middle of this curve. It does have a standard deviation of 7, so if I had to find z-scores to go to a table, I could. But I will be using SALT to help me with this. And I want to find what percentile will a person score if will a person who scored, I forgot a term here, who scores an 80 be in. So an 80 would be on this side. And we want to find out what percentile they would be. Now notice we are above the middle, so we should be above the 50th percentile. I don't know how much above without some help from technology or tables, but that's what I'm going to have to do. So I'm going to be using SALT to help me with these. And we're looking for the percentile. So we're looking for that percentage that's inside there. How many people scored at or below me? And so we're going to go to SALT. Wish there was a way to make this back and forth a little easier, but there is not. So I'm going to do a left tail. I do have to change my mean to be a 65. I do have to change my standard deviation to be the number 7. And we are going less than or equal to that score of 80. So notice he is over here on that side of the 65. It also gives me what z-score he's at. He's at a 2.1429. You can kind of see where he is in relationship to the 1, 2, and 3. And it also gives me that percentage, which I will write as 0.98394, which means that this student who scored that 80 is in the 98th percentile. They are in the 98th percentile. If I had to write that in words. Okay, here's another question based on the same situation. So same mean, same standard deviation. So there's my 65. We want to know what the test score is that represents the 35th percentile. Now 35 is less than 50. So that means I'm down here somewhere. So that this is 35%. Or 0.35. Remembering when we're dealing with our SALT and things, it is giving it to us in percentages, proportions, or probability, which are going to be decimal form. So we're going to go to SALT. And this time we're looking for our score, and we have the percentile. So still a left tail, but the percentile is going to go in the end result. So 0.35, is that the right number? Yes, the 0.35. And then you can look at your picture, make sure everything looks like you want it to. And the test score that does relate to that is a 62.3028. Okay, I think we have one more here. In this particular situation. So the score that represented this 35th percentile was a 62.3 0.028, depending on how many decimals they wanted us to give our answer to. All right. Last question referring to this test. A school decides to give scholarships to students who score in the top 5% of this exam. What is the lowest score that a student can get and qualify for this scholarship? Okay, so still have our mean of 65. And it gives students who score in the top 5%. So that means these students up here. And this is going to be our 5% or 0.05. And we're looking for that score, that test score down here. So remembering all these values along this line are the test scores. The areas represent probabilities, proportions, or percents. And to do this, we're going to go back to SALT. And we still have that 65 and 7. And we want the top, so we're going to go to a right tail. And we want the top 5%, so 0.05. And they would need to score a 76.514 or higher. So again, we went to a right tail and we put that 0.05 in the answer. And there's the test score. And you can look at the picture. You'll see it as well. And we can see all those pieces. And notice it also gives me my z-score if I needed it. So if you were using tables, this is the z-score you would have come up with. Okay, so just kind of be careful when you're doing all these. A lot of times when you're using the tables, make sure most of them work with the bottom half of a situation. So you probably first thing would have to do is look for that 0.95. You could use symmetry as well when you're using those tables. So just be a little bit careful in working with those. But technology today really makes things so much faster. Okay, I do have more examples in my notes for my students, but I do believe that I have shown enough of this for most people. Again, you could do between if you needed to as well, but I think this gives you a nice overview of how you can use SALT to do finding percentiles of problems in a situation. So enjoy the video, and I hope to see you in the next video. Have a great day.